Welcome to another video. Today we're going to be talking about finite geometric series. A geometric series is the sum of the terms of a geometric sequence. So you can see on the left hand side we have sequences, on the right hand side we have series. They are the same exact numbers. The only difference is that sequences are listing the numbers separated by commas, and the series are being added because it's the sum of all the terms of the sequence. We have two formulas here to find the sum of a finite geometric series. These two formulas are also in your formula chart under the sequences and series section. So they're right here where it says finite geometric series. Sometimes they'll use summation notation, sometimes they'll use the S sub n, but the formulas work either way. It does say that r cannot equal 1, because if you put r here, 1 minus 1 would be 0, and 0 on the bottom would give you undefined. So let's compare the two formulas. So if you notice, there are some similarities. So they both have a sub 1, and they also both have r. So for both of them, you're going to need a sub 1 and r. And if you don't know what a sub 1 is, this is the first term. And if you forgot how to find the common ratio, remember that it's the second term divided by the first term. And that's the common ratio. Okay. So how are they different? So one of them has the power of n, and the other one has a sub n. So if you know the total number of terms, then you're going to use the first one. So n represents the total number of terms, and a sub n represents the last term. So if you have the last term, then you would use formula 2. So regardless, for both of them, you're going to need the first term and the common ratio, and then you're going to pick one depending on whether if you have n or if you have the last term. So let's do some examples. We're going to find the sum of the geometric series. There are some things I can label already. The first term, which is 3. The last term is a sub n. And we can also figure out the common ratio. So if you go to your calculator, it was 6 divided by 3. So you do the second number divided by the first number, and then you keep going in that order. So the third number divided by the second number, and you see that they're being multiplied by 2. So it's always times 2 times 2. So this is the common ratio. Okay, so let's look at the formulas that we have. I don't know the number of terms, but I do have the last term, so I'm going to be using formula 2. I recommend you always write the formulas before you start plugging things in, to avoid any mistakes. It's very easy to leave something out if you're not looking. Now, this a sub n r looks kind of weird. So what I recommend is that you just put the r in parentheses so that you know that they're being multiplied, because it kind of looks like it could be to the power of, but it's not to the power, it's being multiplied. And then 1 minus r. So now we'll plug everything in. The first term, 3, minus the last term, times the common ratio, which was 2, all over 1 minus the common ratio, which is 2. So now we're going to type this into the calculator. So 3 minus 12, 288 times 2, and over 1 minus 2, and that gives you 24,573. Now, remember, if you're starting with the first term, you can use S sub n. If you don't start with the first term, then you can't use S sub n, you have to use summation notation. Anyways, the sum was 24,573. Make sure I wrote that right. 24,573. Okay. I want you to pause the video and try number 2 on your own. Okay, now that you've tried number 2, let's move on to number 3. So I can label again my first term, and I have my last term, and I can figure out what the common ratio is by dividing the numbers. So you can do 7, the second number divided by the first number, which was 42, that gives you 1/6, and then it was 7/6 divided by 7, which is also 1/6. So they're being multiplied by 1/6 every time. So this is the common ratio. Okay. So again, we don't know the number of terms, so we're still going to be using formula 2 because we do have the last term. Okay, so we have formula 2. S sub n is equal to the first term minus the last term times the common ratio all over 1 minus r. So the first term, which is 42, minus the last term, which is 42, 1/6 to the power of 8. Sorry, my cat is annoying. Yeah, you can hear her scratching her post. I'm sorry. 1 minus the common ratio, which is 1/6. Oh, I forgot to multiply by the common ratio on the back side of the numerator. Okay, so let's go ahead and type all of that in the calculator. So we have 42 minus 42 times 1/6 to the power of 8 times 1/6 all over 1 minus 1/6. Okay, and you press enter and you get this fraction. So 141.08.773 over 27.99.36. Now, let's say that the calculator gave you a decimal instead. So, oops. If it gave you a decimal, you might have gotten this in your calculator, 50.4. That is being rounded. Remember, we talked about the calculator sometimes rounds for you. And if I press enter, you can see there's actually a lot more decimals there. So it's being rounded. So I don't want you to use the decimal form, because if you round it, it's no longer exact. It's just an approximation. So to convert your decimals to fractions, what you do is first you're going to press, let me erase all this. You're going to go up and highlight your previous answer. So when your answer is in blue, you're going to press enter, and then you're going to do menu, number, and then approximate to fraction. So it should look like this. So it should be the number that you want to convert to a fraction, and then you get the fraction that we had gotten earlier. So whenever possible, just use your fraction so you have an exact answer. Okay. With that being said, go ahead and try number 4 on your own. Pause the video and give it a try. Okay, now that you've tried number 4, let's move on to number 5. Find the sum of the first 6 terms of the geometric series 8 plus 14 plus 24.5 plus ... So when you have the number of terms, so the first 6 terms is going to be your n. We have the first term. Now notice we don't have the last term. I don't know what the last term is, it just ends in ... but we are able to figure out the common ratio by dividing these numbers. So let's go back to our calculator, and we can do 14 divided by 8. We get 7/4. And we do 24.5 divided by 14. We get 1.75. Let's convert that to a fraction. So enter, highlight and enter, and then do menu, number, approximate to fraction. Okay, so they're both 7/4. So we're multiplying by 7/4 every time. So that's going to be our common ratio. Now let's look at our formulas, because this time we don't have the last term, but we have n. So this is when you have the last term, so we're not going to use this one, but we do have n, so we're going to be using formula 1 this time. So that is formula 1, S sub n is equal to a sub 1 times 1 minus r, and this is to the power of n over 1 minus r. Okay, and we can just plug everything in. So 8, 1 minus 7/4, and I'll put the ratio in parentheses so we can raise it to the power of 6, and then 1 over 7/4. Okay, make sure you're using your parentheses because that's going to be important. Okay, so let's go and type that in. So it was 8, and then 1 minus 7/4, to the power of, I keep pressing the wrong number, to the power of 6 over 1 minus the common ratio of 7/4. And we get 37,851 over 128. Okay. Go ahead and try number 6 on your own. Go ahead and pause the video. Okay, now that you've done number 6, let's do number 7 together. Find the sum of the first n terms of a geometric series with a sub 1 equals 3, a sub n is 768, and r equals -2. So this one is pretty easy because you don't have to find anything. They just give you everything that you need. And notice that we have the last term, so we're going to be using formula 2. Which is the first term minus the last term times the common ratio over 1 minus r. So that's 3 minus 768 times -2 over 1 minus -2. Okay, and we're going to type that in the calculator. 3 minus 768 times -2 over 1 minus -2. You get 513. Okay, go ahead and pause the video again and try number 8 on your own. Okay, now that you've done number 8, let's do number 9. So here we have a series in summation notation or in sigma notation. So we have the lower bounds and the upper bounds. That's going to be important. So for starters, to find the first term, you're going to plug in the lower bound. Okay, so the lower bound here is n equals 1, and I'm going to put that into n. So a sub 1 is going to be 5 times 2 to the power of 1 minus 1. And that's the n that I'm plugging in right there. And then we're going to put that in the calculator to get the first term. So 5 times 2 to the power of 1 minus 1 is equal to 5. Okay, now notice that that is the number that was here. If you remember, geometric sequences are written as a sub 1 r to the power of x or t, or I don't know, I forgot already. But the first term is only the first number is only the first term if the lower bound is 1. So to avoid making a mistake, just always plug in the lower bound. Sometimes it will be the same number, sometimes it will not. But to stay on the safe side, just always plug in the lower bound. Okay. Now if you remember from last class period, to find n, that's the number of terms in the series. You're gonna do the upper bound minus the lower bound and then you're going to add 1. So n will be the upper bound 6 minus the lower bound 1, and then always add 1. Okay, and then negative 1 plus 1 cancel out, so you just have n equals 6. Okay, so again, if you remember, the geometric series is a sub 1 times r, so this 2 is going to be your r. That's never going to change. Whatever's in parentheses is your common ratio. Okay, so I don't have the last term. I could figure out the last term. If I plug this in there, I would get the last term. But because I already found n, I'm just going to use the first formula. I'm going to use a different color because it's all blending in. So S sub n is equal to a sub 1 minus r to the power of n all over 1 minus r. Okay, and n is 6, so we're finding the sum of the first 6 terms. A sub 1 was 5. The common ratio is 2. N is 6, and then 1 minus 2. Okay, and here we could use the S sub 6, the S notation, because we're starting with 1, or we could also use the sigma notation, and it'll be the same thing. So remember, if you start at 1, you can use either or. So let's put all this in the calculator. So we had 5, 1 minus 2 to the power of 6 over 1 minus 2, and we get 315. Okay, so there you go. Go ahead and try 10 and 11 by yourself. 10 and 11. Pause the video and try 10 and 11. Alright, now I'm going to do number 12. So notice that this one doesn't start with n equals 1, but it starts with n equals 2. So this is why it's important to find the first term by plugging in the lower bound, because it's not always going to be this one. This is it if you start at n equals 1, but we're starting at n equals 2, so our first term is actually going to be different. So remember, all you're going to do is plug the lower bound into n. So we're going to do 3 times 5 to the power of 2 minus 1. So a sub 1 equals 3 times 5 to the power of 2 minus 1 is 15. Okay. The n, the number of terms, is going to be your lower bound minus, your upper bound minus your lower bound plus 1. So n is equal to 5 plus 1, which is 6. And then your r is whatever is in the parentheses. So r is 5. Okay. You could find the last term if you prefer to do that, like I said in the previous example. But I'm just going to use the first formula again, that we use n instead of the last term. So I'm going to do the first formula. Here I cannot use S sub n because the lower bound is 2, so I am forced to use the sigma notation, which will be the sum from n equals 2 to 7 is equal to the first term times 1 minus the common ratio to the power of n over 1 minus the common ratio. And then let's type that in the calculator. So we have 15 times 1 minus 5 to the power of 6 over 1 minus 5. And you get 58,590. Okay, go ahead and try 13 and 14 by yourself. You can stop the video and just try those on your own. And that concludes this video. I hope you learned something, and I'll see you in the next video. Bye.